Alright, so in this video we're going to talk about plate boundaries. We're going to talk about three types. We're going to talk about divergent boundaries, convergent boundaries, and transform. The first thing I need you to do is picture the cross-section of the Earth like we have right here, and keep in mind that when we talk about the Earth's plates, we're talking about what's called the lithosphere, which is the very top part of the Earth. If we look at a cross-section, it consists of the crust and the top part of the mantle, and this is what we call the lithosphere. I'll try and write that for you right here. L-I-T-H, forgot my I, T-H-O-S-P-H-E-R-E. That is the lithosphere, and it floats on top of the remaining part of the mantle. Let me grab a different color here. The lower part of the mantle, this part right here, not just hard green. Let's go to blue. This part right here, this lower part of the mantle is what we call the A-S-T-H-E-N-O-S-P-H-E-R-E, the asthenosphere. Okay, so this is like a plastic-like material that allows these convection cells to churn, which drive the movement of the plates. So just keep that in mind as we move through this. When we're talking about plates, that's what we are talking about. So we'll move right along. We'll start talking about divergent boundaries. These are the boundaries at the spreading centers like we've talked about. In this situation, we have the lithosphere. Here you see lithosphere and the asthenosphere. And these plates are diverging. They go apart, like the Robert Frost poem, "Two roads diverged in a yellow path, and I took the one less traveled by." These two go apart or diverge. When they diverge, new magma comes up and solidifies and creates new crust. This is where new crust is formed. And this is basically a cross-section of the mid-Atlantic ridge. Here's the middle of the ocean. These plates are spreading apart, and there's a constant flow of slow-moving volcanoes sort of out here that's along this mid-Atlantic ridge. So some of the results of a divergent boundary are in the initial stages, you just sort of get a warping or this lifting of the crust, as you see right here, of the continental crust. And then these, go back, sorry about that. As these plates start to move apart, you start to get what's called a rift valley. This is what you get in East Africa. This is where they do lots of fossil digs. And the reason that those are great is because it pulls this land apart and allows you to see lower levels, lower strata is what we call that, within the Earth. And so this Earth is sort of pulled apart, and you get this layering system set up here. And that's a good place to find fossils. As it continues to spread, water soon fills this area, as we see here. So this would be the example of the Atlantic Ocean. Here's Pangaea. Pangaea starts to split apart, and water rushes in and starts to form the Atlantic Ocean. And as it gets wider and wider, our ocean gets older and older and broader. It's growing about an inch a year, or 2 centimeters or so, just to give you some perspective, like we mentioned in class. And that is a divergent boundary. So to recap, divergent boundaries are plates moving away from each other. New crust is formed there, and this is an actual satellite image of the Atlantic Ocean. Here's the United States. Here's Kentucky. We're sitting right off the map. This is Africa. Here's Europe up here. And this is the actual mid-Atlantic ridge, and this is the spreading center. It's actually, people think that it's the most deep part of the ocean, and actually it's not. It's rather shallow out there towards the mid-Atlantic ridge. The deepest part is actually over here in the trenches that we'll talk about in just a little bit. So one example of spreading divergent boundary is the mid-Atlantic ridge. Also, the East African Rift Valley, like we just talked about. This is a big fossil digging spot. And the next thing we're going to talk about are transform boundaries. Transforms when two plates shift past each other horizontally. So notice they're not going towards each other or away from each other, they're sliding. This one is sliding up this way, and this guy's sliding back down this way. They're moving past each other horizontally. Crust is not created or destroyed at these, it's just shifted. So what happens is pressure just builds up and builds up and builds up if you had your two hands sliding past each other, and they keep building up, building up, building up, and sooner or later they slip. And when they slip, we get an earthquake. So the results of a transform fault boundary are earthquakes. And if that earthquake happens to occur underwater, that's where we get a tsunami. Granted, tsunamis can occur from other types of shifts of plates, like we'll talk about in a little while, but most of the large earthquakes come from transforms. An example of this is the San Andreas Fault in California, right up through here, that basically splits Los Angeles and San Francisco. And as you see, this plate is rotating up this way. See how they're transforming? They're sliding past each other here with these two arrows. And so what happens is this little leg right here of California, the peninsula, shifts up this way. And as it shifts up this way, people say that California is falling off into the ocean. It's technically not falling off into the ocean, but this part is shifting up further and further. So sooner or later, if you could imagine, Los Angeles could be up here, parallel or next to San Francisco. This is the actual fault that we got to feel a little bit of movement from when we were in San Francisco this past year. The next plate boundary that we want to talk about is convergent plate boundaries. Convergent plate boundaries, there's two types. Actually, there's two types of plates, excuse me. There's oceanic plates and continental plates. So given two plates, there's three possible conditions for collisions. And I know you math people are saying, oh, so if we got two variables, there's three possible setups. We could have continent to continent, ocean to ocean, or ocean to continent. So those we'll talk about independently of each other. The first one is continent to continent. This is when we get mountains. So this continental plate and this continental plate, as they crash together, as you can see, this one sort of subducts underneath the other one, but mainly they just create this big bulge right here that gives us our mountain range. That's how we got the Appalachian Mountains from way back when the Americas were together with Africa and Europe. It is also how we get, or let me go over a few things here, slow-moving plate boundaries. We get mountains built, and we get old crust destroyed. An example, here we are, I was just talking about the Appalachian Mountains, which are right here. They formed way back when, during Pangea, when all the continents, the supercontinent, all the continents were mushed together from a continent-to-continent collision. And just as the Himalayan mountains, where the Indian plate is crashing into the Eurasian plate, and when it does that, it's building a mountain range right here, which is what we call the Himalayas. Mount Everest is right here. It's the tallest mountain above sea level. It continues to grow each year. The reason that it is growing is because this plate is still moving this way, crashing into this plate, and since they're still crashing together, these mountains are still building up and getting taller and taller. So there's an example of continent to continent. Now, when we get ocean to ocean, you basically get the same thing. You got two plates of similar density, and when they collide, you again get things start to build up, but we start to destroy old ocean crust, and volcanoes build now. Because of that less dense oceanic crust dives down underneath, and as it heats up, it comes back to the surface through various routes. And that's where we get what are called island arcs. An example of an island arc are the Aleutian Islands. They're up, so if this is the U.S., the Aleutian Islands are up here between Alaska and Siberia. Feel free to Google that, look it up on a map. Oh, wait, never mind. Here it comes. I forgot I had this in here. Here are your Aleutian Islands right up here, because we get this collision between the Pacific plate and this plate right here. They're colliding, and we get the Aleutian Islands, which are really just a chain of volcanoes. Now, the big one is when we get ocean to continent. When ocean to continent occurs, well, let me go back to that for just a second before I continue. We get what's called a subduction zone. make sure that you are familiar with this term, subduction zone. A subduction zone is when one plate dives beneath the other. In this situation, your oceanic plate is diving beneath the continental plate because it is less dense. It is more dense, so it's going to go underneath. The less dense continental plate sits on top. Little technical difficulties here. See if I can sort this out. There we go. Sorry about that. Wipe this clean. So, ocean, which is more dense, subducts underneath the less dense continental crust. It destroys old crust, just as we saw in class with our little model. This is where you get the deepest part of the ocean. Earlier we were talking about the mid-Atlantic ridge not being the deepest part of the ocean. It's not in the middle of the ocean. Rather, it's at what's called the trench. This is where we get composite volcanoes to form. Composite volcanoes are the most deadly volcanoes. They're the volcanoes you want to stay far, far away from. We'll come back and talk about that in just a little bit. Some examples of this are Mount Vesuvius, which destroyed Pompeii in 79 AD. And this is famous because it instantaneously buried an entire city, and now we've excavated most of it, and we can see people just running away from their out of their houses. People were asleep in the bed, and they just got buried in ash immediately. This is the type of volcano you cannot escape. Another example closer to home is Mount St. Helens. Mount St. Helens, I guess just like 5 years ago, they thought it was going to erupt, so they evacuated the entire area. Fortunately, it did not. And we'll stop right there for this video. We'll come back in just a little bit and talk about volcanoes and wrap this up.